In this video, we are going to see the study on steam generators and turbines. So the aim of the experiment is to study the working of various types of steam generator, which means steam boilers. So first we must know what is meant by steam generator. A steam boiler is a closed vessel which boils water and generates steam by transferring heat produced by burning of fuel to water. The steam boiler produced is used for power generation or for process heating. So how will you select these steam generators? So that is the selection of type and size of the steam generator depends upon the following factors. So first one, what is the power required and working pressure? Second one is the geographical position of powerhouse. Third one is the fuel and water availability, and fourth one is probable load factors. So how will you classify steam boilers? So that is, the steam boilers are classified according to the following types. So first one, flow of water and heat gases. So in this we are having fire tube boiler and water tube boiler. And second one is method of firing. So that is internally fired or externally fired. And third one is the method of water circulation, whether it is natural circulation or forced circulation. And fourth one is pressure developed. So whether it is low pressure boiler or high pressure boiler. And fifth one, nature of service, which is stationary boiler or mobile boiler. And sixth one is design of gas passage, single phase or multi-phase. So now we will consider high pressure boilers, so which we are taking into account nowadays. So modern high pressure boilers generate steam at a pressure more than 75 bar. So for this we are considering the example as Babcock and Wilcox boiler, Lamport boiler, Lamont boiler, BHL boiler. So what is Lamont boiler is a forced circulating boiler, so which was introduced in 1725 by Lamont. So hence the name came as Lamont boiler. The arrangement is shown. The most sensible heat is supplied to the feed water passing to the economizer. So a centrifugal pump circulates the water equal to 8 to 10 times the weight of steam evaporated tubes and the part of water supplied drum. The large quantity of water circulated prevents the tubes from being overheated. To secure the uniform flow of feed water through each of parallel boilers circuit, a choke is fitted to enhance each circuits. Next, BHL boilers. It consists of feed pump, a economizer, a boiler drum, radiant and convective superheaters, FD fan, air preheaters, electrostatic precipitator and chimney. The feed water from the hot well is pumped with the help of a feed pump to boiler from the economy. The boiler drawn, the feed water is circulated to number of valves in the furnace where the fuel is burnt. The feed water is evaporated into wet steam and the wet steam flows back to boiler, which is drawn. In this it is supplied to prime mover through the steam outlet. So this is an schematic of your boiler. The hot flue gases from the furnace passes over radiant and convective superheaters to superheat the steam. Then it passes to the preheaters, economizer and preheater. Then the flue gases passes to the electrostatic precipitator. So this is the working of steam generator and hence it is studied. The next one is to study the working and classification of steam turbines. So generally the steam turbines are classified into two. One is impulse turbines and another one is reaction turbine. A steam turbine has basically have a nozzle and a ring of moving blades mounted on a shaft which is called as a rotor. The shaft motion of turbine depends solely upon dynamic action of the steam. Steam is injected through nozzles over to the rings of the moving blades. Thermal energy of steam is partly converted into kinetic energy due to static pressure drop in the nozzle. High velocity steam which is leaving the nozzle enters the moving blade and the direction of the steam flow gets changed from the inlet to exit. So this change in direction of steam flow causes change of momentum which results in dynamic force acting as driving thrust for rotation of the shaft. Steam turbine can be impulse turbine or reaction turbine based on the mechanism of driving thrust creation. If the static pressure drop occurs principally in the stationary nozzle with little or no static pressure drop occurring in rotor blade passage, then that turbine is called as impulse turbine. If the substantial static pressure drop occurs in the stationary nozzle and rotor blade passage, both, then turbine is called reaction turbine. Thus, in case of impulse turbine, driving thrust is available due to change in momentum because of change in velocity direction while moving across the blade from inlet to exit. In case of reaction turbine, the static pressure drop in rotor blade passage causes further conversion of thermal energy into kinetic energy and hence generation of resultant reactive force. And driving thrust in reaction turbine comprises of reactive force and force associated with change in momentum due to change in direction of velocity. Impulse turbine has basically following components which are to be described here. So next we are going to see what are the different components of the turbines. So first one is the stationary nozzle. Impulse turbine has stationary passage comprising of one or more stationary nozzles in which steam at high static pressure and low velocity is expanded so as to increase the velocity of steam at exit of nozzle. High velocity steam leaves nozzle so as to deliver steam with correct direction for smooth entry into moving blades. So this is the function of stationary nozzle. Then that steam goes to the moving blades. So what is moving blades? Moving blades are fixed around the circumference of a rotor shaft with the top of blades connected together for rigidity by means of a blade shroud rings. Blades actually cause change in direction of steam and so the momentum change occurs and thus impulse is generated. Steam turbine blades are made of alloy steel and manufactured by machining from bare stock. Typical blade material called nickel based superalloy may have nickel like materials for their manufacturing. Next, guide blades. So turbine rotor has guide blades prior to moving blades so as to guide the steam in proper direction for smooth entry into moving blades. Guide blades are stationary guides mounted between the rotor blade rings. Guide blades perform function of reversing the direction of steam leaving and proceeding moving blade row so that the direction of steam entering moving blade rows is similar. The next one is a casing. Casing refers to the outer enclosure housing nozzles and fixed blades. Chasing is also referred to as a cell or a cylinder. Chasing confines steam to flow passages and also provides the structural frame. Casings of large steam turbines are normally horizontal, split from convenience of repair and inspection. For high pressures and temperatures, casings are made of carbon steel, while low pressure turbine casings are made from rotor flat steel plate. For very high temperatures, stainless steel casings are good. So next component is shaft. Shaft or rotor or spindle, which refers to the rotating member upon which a moving blade ring is mounted. Ring or wheel. Wheel refers to ring upon which moving blades are mounted. Wheel is keyed onto the shaft. This ring is called a disc. Next is diaphragm. So diaphragm is attached to the chasing containing the nozzles and performs the functions of confining steam flow to nozzle passage. So next one is a packing. So packing is provided for preventing the leakage across the annular space between the diaphragm and shaft, chase and shaft. Packing is provided in the form of carbon rings. Carbon rings present an effective seal against shaft leakage in small turbines and are extensively used with water seals for preventing shaft leakage in larger turbines. Carbon ring consists of a ring or carbon rectangular in cross section and usually divided into 4 segments. Rings fit into a recess in chasing and are kept tight against the shaft by means of a greater spring. Labyrinth seals consists of series of thin strips fixed to the chasing or other stationary member and arranged so as to maintain the smallest possible clearance with the shaft. The lamprey seals have small restrictions that increases the velocity of fluid leakage only to have it dissipated into the pockets, thereby throttling the fluids. The tips of the strips are extremely thin so that if rubbing occurs, the tip gets worn away without damaging the shaft. So this labyrinth seals do not prevent complete leakage of the fluid. So these are effective in only reducing the leakage. So complete leakage prevention is done in association with other seals as carbon seals described earlier. So next one is steam's chest. So this is the steam supply chamber which houses steam before being supplied to the nozzles. Next is exhaust hood, the portion of chasing which collects and delivers exhaust steam to exhaust pipe or condenser is called exhaust hood. Throttle valve. So throttle valve, also called stop valve, is located in steam supply line of the steam turbine. Throttle valve may be manually operated or hydraulically operated for regulating steam flow during start and stop of turbine. So next one is the governor. So governor is also provided in steam turbines for controlling the steam mass flow rate so as to maintain constant speed with load fluctuations. An overspeed governor with trip mechanism is also provided to shut off the supply of steam. Next is bearings. Turbines has many bearings to support the shaft. Along with these, thrust bearings are also provided to support the axial thrust. Next is turning gear. So turning gear is generally used with large turbines and consists of a gear integral with turbine shaft driven by electric motor through necessary speed reduction. Turning gear is used so as to keep the turbine shaft rotating at about 1 to 20 rpm in order to avoid springing of shaft occurring due to unequal expansions and contractions during warming and cooling of the turbine. So next is what is meant by trip mechanism is steam turbine is provided with trip mechanism operating through an overspeed governor to shut off supply of steam to turbine. Trip mechanism is actually safety device so which gets activated upon number of other adverse operating conditions of turbine such as loss of lubricating oil pressure or condenser vacuum or excessive axial thrust, etc. So thus in this video we have learnt about the working of steam generators and steam turbines and its types. Thank you.